Okay, let's give you guys some more practice. So work out the arc length from here to here, from 0 to pi over 2. So press pause and have a go. Okay, so to do this, to work out the arc length, we would need to square the r. So we've got to put this into the r, and then we also need to work out dr by d theta. So looking at this, we need to work out dr by d theta. So looking at this, looking at this, dr by d theta equals this, and then tidy this thing up. This will then become this, and then when you square it, it will then become this. So now we've got dr by d theta squared. We can now put it into the formula. So dr by d theta squared equals this thing here. So we can put this thing here into here, and then earlier we knew r, so we can put it into there. So this whole thing here will become this. And remember, we're integrating from theta equals 0 all the way to theta equals pi over 2. So putting this into here will then become this, and then put r into there, it will then become this. And then now tidy up, tidy this thing up, it will then become this, because well, here you've got one fraction, here you've got another fraction. Get the two denominators to be the same. So here times top and bottom by 1 plus cos theta squared, and then 1 plus cos theta squared, and then merge the two fractions. That will then give you this, and then tidy this up. It will then become this. So from here, multiply this out. That will then give you this. And then from here, hang on, let me think. From here, multiply this out. So that will then give you this. And then now you can see cos squared, sine squared. So you can factor out. Well, you can merge those two together. That will then give you this. And don't forget, this thing here is 1. Okay, so from here, that will then take you to here. And then looking at this, you can see that in here you can have this. You can factor out the 72. That will then give you this. That will then give you this, and then this will cancel out with this. So that then becomes a 3. Well, think about it. From here, that will then take you to here, and then these two. Well, this will cancel out with one of these. Okay, so that will then take you to here. So from here, remember this. We are trying to integrate this whole thing here. Looking at this, we can make use of this. We've seen this before. If you multiply both sides by 2, that will then give you this. And if you look at this is very similar to this. Something that you should bear in mind is that this angle here is twice the size of this angle here. So if you've got this here, so remember, this angle here is twice the angle here. So when you make this substitution, if you look at this here, this angle here is twice the angle here. Well, think about it. Make use of this, substitute into here. That will then become this. So this thing here will then become this. Okay, and then from here, so here you've got a block of 2 times this thing here, and then you've got to cube it. So you've got this thing here times that block, and then times it by itself 3 times. And then this times this times this, that will then give you 8. This times this times this, that will then give you this. So from here, that will then take you to here, and then let me think, and then from here, remember root a over root b equals root blah blah blah. Here, that will then give you this, and then break it up. That will then break. Well, if you look at this, remember root a b is the same as root a times root b. So you can actually break this up into two square roots here, and then factor this out. So that will then give you this, and then you've got the 1 here. That will then give you this. Think about it. It will take you to here, and then let me think, and then this here, what? Yeah, square root this. That will then give you this, and then from here, well, square root this bit. That will then give you this bit here. Okay, and then what? Let me think. And then this here is a constant. You can take it out. Oh yeah, this here is 3. You can take it out. This here is 3. I will continue in the next video. Okay.